The concept, measurement, and partitioning of variance is fundamental in statistics. There are plenty of websites and videos that will give you technical definitions, formulas, and incredibly detailed examples. I care much more about making sure that the concept makes intuitive sense to you. So, here we go. Do me a favor, look through these data and tell me how different these numbers are from one another. How much do they vary? Since all of the numbers are exactly the same, the variable is considered to be a constant. It has zero variance. Nothing changes from case to case. What about now? Now how much variance is there? Only a little bit, right? When I gave you this set with no variance, you always knew what to expect. No matter what, the number listed in column X for every person was always going to be 5. But in this example, the value for X depends on which person it is. You can't just guess 5 anymore and expect to be perfectly right. Not everyone's answer was 5. What this means is that variance introduces uncertainty. One of the major points of statistics is to explain things that are uncertain. I contend that you already intuitively understand this process. Here, let me show you. Let's play a little game. What's the pattern in these data? Awkward silence. And yeah, of course, it's just x plus 1 equals y. So you can basically just add 1 to the x column and get the y column. You can see that there's a pattern between x and y. That pattern could be more difficult to discern. So for instance, what's the pattern here? Now, of course, we're just squaring x to get our y value. In both of these cases, what's really happening here is that the x value is helping us to predict what's going to be the y value. Like, look at example 1 again. If I gave you x equals 8, you would say y would equal 9. Example 2, x equals 8, y equals 64. What does this pattern recognition have to do with variance? Well, look again at this y column. There is some variance in that y column, correct? There is variance in these data. If what I said before is true, variance equals uncertainty, then we want to explain the uncertainty. And of course, we're going to use x to help us do that. Even though there's a lot of variance in y in this example, we can use x to perfectly predict what y is going to be, because we found the pattern. But here's a tricky one. You might want to pause the video to look at this and see if you can find the pattern. I'm sorry, but it's a little bit of a trick question. There isn't an exact pattern. X does not perfectly predict Y in that case. While that means that these meaty brains of ours have to give up, statistics can still find patterns even if prediction isn't perfect. What statistics would say is that you can use this formula to get the Y value for those data, but you're often going to be just a little bit off. What this is really saying is that you could use this formula to get close to Y, but there's also some error, and we haven't explained that error. We don't know what's going on there. We don't know what it is. So I want to extend my assertion from earlier. Error also equals uncertainty, which equals unexplained variance, the variance that we haven't accounted for, the variance that we don't know what's going on. To restate, X can help us to explain or predict Y. It won't always be able to do it perfectly. So what do I really want you to take away from this? Variance has to do with how different the data points are from one another within a particular variable, and that is uncertainty. We can employ statistical models using other variables to help us explain at least some of that uncertainty.